Hello, everyone. Welcome. Hi, I'm Oliver.
Hi, I'm Lily.
Welcome to Science and Easy English. Today, we are exploring one simple question. Why does pain exist?
Yeah, and it's a question that gets really strange really quickly when you start looking into it.
It really does. Because right now, somewhere out in the ocean, there is a species of squid that intentionally paralyzes itself with terror after just a minor scrape.
Right, which sounds completely counterproductive.
Exactly. But understanding why that squid does that might actually be the key to curing human back pain. So for this deep dive, we are taking a massive stack of scientific papers, evolutionary biology research, and, cutting-edge medical literature to figure out what pain actually is.
Because if you were listening to this, you have obviously experienced pain.
Right, everybody has.
Yeah, and usually we expect our bodies to operate with this, mechanical precision. You touch a hot stove, a sensor trips, an alarm rings, and you pull your hand away. It's just direct cause and effect.
Which is super helpful.
It is. But when you step into the world of chronic pain, that beautifully wired house just descends into absolute chaos. The alarm is blaring at 3 in the morning, but there's no smoke, there's no fire, no burglar, just endless noise.
Which is incredibly frustrating for anyone dealing with it. And to understand why that system glitches like that, we really have to define what pain actually is, and more importantly, where it lives in the body.
Which has historically been a huge point of confusion.
Yeah, totally. I was reading through the 2023 Manifesto in Defense of Pain Complexity, which was in our stack of sources, and they make this very sharp distinction between nociception and actual pain. These are treated as two completely different things.
They absolutely are. So the International Association for the Study of Pain defines pain as an aversive, unpleasant sensory and emotional experience.
Okay, an emotional experience.
Right. Nociception, on the other hand, is just the biological hardware doing its job. It's your nervous system's physical process of encoding a harmful stimulus.
But the actual wiring?
Exactly. When you step on a nail, nociceptors, which are these specialized sensory neurons, they detect the tissue damage, and they shoot an electrical signal up your spinal cord to your brain.
But that signal itself isn't pain.
No, not yet. That electrical impulse traveling up your spine, it's just data.
It's like your home security camera quietly recording a video of a window breaking in your living room. The camera capturing that event isn't the emergency itself.
That's a great way to put it.
Right. Pain is the homeowner actually waking up, seeing the footage, feeling a massive spike of panic, and calling the police. The panic is the conscious reaction to the data.
And that separation between data and conscious reaction is the battleground for a massive debate in neuroscience right now.
Yeah.
Because there's this very trendy movement claiming that, well, because the brain interprets the data, pain is purely an output of the brain.
Which the 2023 Manifesto pushes back against pretty heavily, right?
Very heavily.
Okay.
They argue that claiming pain is solely generated by the brain commits what philosophers call the mereological fallacy.
The mereological fallacy, that's the logical error of attributing the properties of a massive, complex system to just one single part of it.
Correct. You can't just attribute the rich, complex experience of pain solely to the brain while completely ignoring the peripheral nervous system or the localized immune response at the site of the injury.
Or your hormones or your environment.
Exactly. It's the equivalent of pointing at a steering wheel and saying it's the sole reason a car is able to drive down the highway. Pain is an emergent property of your entire biological and psychological system interacting all at once.
And I really have to advocate for the listener here because this whole brain-centric trend has real-world consequences.
Oh, absolutely.
Because when people who are living with debilitating chronic pain hear the phrase, pain is constructed by the brain, what they actually hear is, it's all in your head.
Right, which feels incredibly dismissive.
Yeah, as if they're just, imagining their suffering. But the literature completely validates that pain is a full-body biopsychosocial event. It is happening to your whole self, not just your imagination.
Which forces us to look at the entire organism, to really understand why we suffer so much for things that honestly aren't even life-threatening.
Like a paper cut.
Yeah, exactly.
Hmm.
If this is a full-body alarm system designed to protect us, we have to look at the evolutionary medicine perspective.
Hmm.
Specifically, the work of researchers like Nessie and Shulkin. They outline this thing called the smoke detector principle.
Nature's ultimate cost-benefit analysis.
Yes. The idea is that it is immensely cheaper to have a false alarm than it is to miss a real fire.
So if an ancient human is out gathering food and hears a rustle in the tall grass, their brain might trigger this intense fear and pain anticipation response.
Right. And if it turns out to just be the wind, what happens? The human wastes a few calories of energy and has a moment of stress.
But if the brain assumes it's just the wind and it actually turns out to be a predator?
The cost is the organism's life. The genetic line literally ends right there.
Wow. Yeah, that's a steep penalty.
So natural selection heavily favors a hypersensitive alarm system. We evolved to feel pain that seems entirely excessive because that excess guarantees we pay attention.
And the sources highlight just how vital that annoying sensitivity is by pointing out people who actually don't have it.
Yes, the pain deficiency syndromes.
Right, like congenital insensitivity to pain, where individuals literally cannot feel physical pain. And, on the surface, never feeling a stubbed toe or a tension headache sounds kind of amazing.
It sounds like a superpower, but the reality is incredibly grim.
Yeah.
Children born with this condition often chew right through their own lips and tongues without even realizing it.
Oh, it's awful.
It gets worse. They suffer massive, irreversible joint damage, what doctors call Charcot joints, because they lack the micropains that tell the rest of us to shift our weight when we've been standing or sitting in one position for too long.
Oh, right. Just that slight ache that makes you cross your legs or shift in your chair. They don't have that.
They don't.
Yeah.
And they frequently die young from ruptured appendixes or severe internal infections, simply because the early warning sirens don't exist in their bodies.
It is the ultimate proof that you would rather deal with a hypersensitive smoke detector going off every time you burn a piece of toast than wake up to your house entirely engulfed in flames.
Exactly. But the catch is, our modern world is actually exacerbating this system. Researchers call this evolutionary mismatch.
How does that work?
Well, we evolved in an environment full of constant, minor physical traumas. Barefoot walking, scrapes, intense physical exertion. So our baseline pain sensitivity was calibrated for a harsh, highly stimulating world.
But today, we sit in climate-controlled offices.
Right, in ergonomic chairs, moving very little. And because our nervous systems lack that constant low-level physical feedback, our heavily calibrated alarm systems are left constantly searching for a signal.
So they become hyperreactive to incredibly minor stimuli. Okay, so a false alarm for a cramped neck from staring at a monitor makes sense. But that eventually fades. What about chronic pain? Because I was looking at the 2019 Edgar T. Walters paper, and initially I was completely skeptical of his premise.
It is a very build theory.
Yeah, he theorizes that agonizing months-long chronic pain is actually an evolutionary advantage. And that just seems entirely contradictory to me. Like, how does a 5-year migraine or chronic lower back pain offer any survival benefit?
To understand it, it really requires looking at survival after a massive trauma. Walters argues that chronic, ongoing activity in our nociceptors, those danger-sensing nerves we talked about, actually enhanced our evolutionary fitness by forcing an injured animal into a state of extreme hypervigilance.
Yeah, okay. So picture an animal in the wild that has just survived a major predator attack but is severely wounded.
Exactly. It's bleeding, it's limping, and it is highly vulnerable. It is prime prey.
So the misery is the mechanism. The ongoing pain ensures the animal hides, avoids confrontation, and basically just rests.
Yes. It essentially paralyzes them with caution. You mentioned the squid earlier. Walter's research highlights that when squids suffer a peripheral injury, they exhibit long-term tactile and visual sensitization.
Meaning their sensory thresholds drop drastically.
Right. They become terrified of even the smallest shadow or vibration, and that keeps them hidden away from predators while their tissues physically repair.
Okay, this could make sense. But the forensic evidence from the dinosaur fossils was even more compelling to me.
Oh, the theropod. That was fascinating.
Yeah. The literature mentions a specific theropod dinosaur that had a record-breaking number of healed bone maladies. We're talking fractured ribs, arm injuries, and severe bone infections.
And the critical detail there is that those bones calcified and healed.
Right. That means the dinosaur lived for months, possibly years, after sustaining injuries that would have made it incredibly slow and weak.
And the only way an apex predator survives that long while disabled is if chronic pain forced it to completely alter its behavior and just hide out until it recovered.
We see the exact same mechanism today in African hyenas, right? Surviving traumatic amputations in the wild.
Yes, they lose an entire limb in a snare or a fight, but their pain-driven behavior forces them to adapt, avoid larger threats, and somehow survive.
Okay, so this makes perfect sense if you are a dinosaur hiding in a swamp or a squid avoiding a shark. But how does this translate to a modern human listener?
What do you mean?
Well, we don't really hide when we're in chronic pain. We wince, we limp, we complain to our families. If the evolutionary goal is to avoid predators, shouldn't we instinctively mask our injuries so we don't look weak to a passing threat?
That is exactly where human social dynamics complicate the whole picture. We aren't solitary theropods. We are highly social primates who rely on our tribes for survival.
Right.
So Leigh and colleagues published this fascinating research in 2025, exploring how the expression of pain functions within a community. They proposed that expressing pain symptoms evolved a critical secondary function.
To act as a subconscious social signal to elicit help.
Pers-
I read through their sibling experiment, and the methodology was just brilliant.
Oh, it was so clever.
They had participants read various scenarios about a sibling dealing with a chronic illness. Sometimes the sibling expressed no outward pain, sometimes moderate pain, and sometimes severe pain symptoms.
And the underlying severity of the actual disease didn't even matter.
That blew my mind.
Yeah, whether the illness was described as objectively life-threatening or quite wild, the mere expression of moderate to severe pain symptoms significantly increased the participants' willingness to just drop what they were doing and help.
So the physical symptom itself is a trigger for community empathy.
Yes.
It's exactly like a car's hazard lights. Like when you press that button on your dashboard, it doesn't just tell you that your engine is failing.
Right, it broadcasts a signal.
A bright flashing signal to everyone else on the road to pay attention, slow down, and offer space or assistance. Human pain expression is literally a biological hazard light.
It taps into the hardwired empathy of the group, so you don't get left behind by the nomadic tribe when you sprain your ankle. It creates a community of helpers.
Which is beautiful in a way, but, as illuminating as that is, knowing why your hazard lights are flashing doesn't make living with them any easier when you're just stuck in traffic.
No, it really doesn't.
Because your nervous system doesn't know you work in an office and are perfectly safe from predators, it feels a bulging disc in your back and fires up a multi-million-year-old survival script, cranking up the pain to force you into a cave.
We are suffering from a brilliant, ancient mechanism that is often completely useless in modern life.
So if our bodies are effectively stuck broadcasting these hazard lights because of an evolutionary glitch, are we just doomed to suffer? Or can we manually hotwire the system to shut the lights off?
Well, the literature points out that the brain essentially acts as a volume dial for pain, and that dial is heavily influenced by context.
Context is everything.
Consider the physical act of stubbing your toe. The physical force, the nociceptive input might be identical in two different scenarios. But if you stub your toe when you are late for work, severely stressed, and running on 2 hours of sleep, the pain is just excruciating.
Because your brain's threat level is already elevated.
Exactly. So it interprets this new data as a major crisis and turns the volume dial up to 10.
But if you stub that exact same toe with the exact same force while you're at a party, laughing with your closest friends, you barely even register it.
Because you feel safe, socially connected, and relaxed. The brain receives the exact same electrical data from the toe, assesses the safe context, and just turns the volume dial down to a 2.
Okay, so that's the natural volume dial. But scientists have actually figured out how to hack that dial directly for people whose internal dials are just, jammed at a 10, right?
Yes, through clinical neuromodulation, specifically spinal cord stimulation, or SCS. It involves implanting tiny electrodes in the epidural space near the dorsal columns of the spinal cord.
It's basically like a pacemaker for your nervous system.
That is exactly what it is.
But is this just for extreme rare cases? Let's ground this in something incredibly common from the literature, like painful diabetic neuropathy. Millions of people deal with this.
It's a huge issue. High blood sugar physically damages the peripheral nerves in the legs and feet, causing them to spontaneously misfire and send agonizing burning signals to the brain, even when there is no external threat.
So it's a completely false alarm.
A constant false alarm. Historically, older models of spinal cord stimulation tried to treat conditions like this by sending low-frequency electrical currents to intercept those misfiring signals.
But there was a major trade-off.
Yeah, it caused a constant tingling sensation called paresthesia. You were essentially trading the sensation of pain for this vibrating, buzzing feeling.
Which doesn't sound ideal, but the new breakthroughs detailed in our sources talk about 10 kilohertz high-frequency stimulation and burst SCS.
The shift to 10 kilohertz, meaning 10,000 electrical pulses per second, is revolutionary.
Wow, 10,000 a second.
Yeah, and because the frequency is so incredibly fast, it doesn't trigger the larger sensory nerve fibers that cause that tingling sensation. The patient feels absolutely nothing but the absence of pain.
That's incredible.
The electrical pulses seamlessly intercept the flawed data from the damaged diabetic nerves before it ever reaches the brain's conscious awareness.
But the literature mentions this goes way beyond just like jamming a radio signal. It's not just static blocking a broadcast. When I was reading the breakdown of the mechanism, it specifically highlighted the role of GABA.
Yes, we aren't just blocking the nerve. The electricity is actually forcing the spinal cord to release more of this specific neurotransmitter.
This is where the biology gets truly fascinating for me, because GABA, or gamma-aminobutyric acid, is your nervous system's primary inhibitory neurotransmitter, right?
It is the chemical equivalent of putting your foot firmly on the brake pedal. When the high-frequency electrical pulses hit the spinal cord, they stimulate specific interneurons to release GABA. And at a cellular level, that GABA binds to the hyperactive pain neurons and literally opens up their chloride channels.
And then negatively charged chloride ions flood into the cell.
Exactly, which hyperpolarizes it.
Meaning it chemically forces the nerve cell to just power down. It makes it nearly impossible for that nerve to fire off a pain signal.
Right. You are using an electrical implant to trigger a localized chemical cascade that actively quiets the hyperactive circuits. And it actually goes even deeper.
Deeper how?
The high-frequency stimulation has been shown to reduce neuroinflammation, the localized swelling of the nervous tissue itself. And over time, it actually modulates the neuroplasticity of the brain.
Neuroplasticity, so the brain's ability to physically rewire itself.
Exactly. Chronic pain is essentially a disease of neuroplasticity. When you are in pain for years, the physical synapses in your brain restructure themselves. The pathways dedicated to processing pain become thick, efficient, and highly sensitive.
While the pathways dedicated to pain suppression just wither away.
Yes. SCS helps restore that functional balance. By cutting off the constant flood of panic signals from the damaged nerves, the brain's pain pathways begin to weaken from lack of use, and the suppression pathways regrow.
So the electricity literally teaches the nervous system how to heal its own glitch.
It's astounding.
That really is staggering. We are using microscopic electrodes to correct an evolutionary mismatch and chemically force a biological smoke detector to finally just reset.
But obviously not everyone listening to this can or should run out and get an implant in their spine.
Right, right. So how does understanding this volume dial help the listener right now, today, in their daily reality?
Well, studies show that simply learning about the neuroscience of pain, just understanding how this complex contextual alarm system works, has been clinically shown to reduce the actual physical experience of it.
Wait, really? Just learning about it helps?
Yes. When you understand that an unexpected spike in your chronic back pain might just be your nervous system reacting to a stressful day at work rather than new physical tissue damage, you reduce the fear associated with the pain,
And by lowering the fear, you lower the brain's threat level.
which physically turns down your internal volume dial. Knowledge literally is pain relief.
That is just phenomenal. Let's take a breath and look at the incredible ground we've covered today. For everyone listening, we have explored the fundamental difference between physical nerve data and the conscious panic of pain.
We've looked at annoying evolutionary smoke detectors that favor false alarms to keep us alive.
We've examined paranoid squids and heavily armored dinosaurs using chronic misery to survive severe injuries.
We've seen how our pain acts as a social hazard light, violently flashing to build a community of empathetic helpers.
And finally, we explored the cellular mechanics of high-tech spinal pacemakers, releasing neurotransmitters to rewire our brains and silence alarms we no longer need.
It fundamentally changes how you view your own body, but it also raises a deeply philosophical question to leave you with.
Oh, what's that?
If modern medical technology eventually allows us to flawlessly hotwire our nervous systems, like to completely mute our brain's pain volume dials on demand, will we inadvertently lose a fundamental part of the human experience?
That's a profound point.
If we possess the technology to permanently shut off our hazard lights, will we lose the very mechanism that keeps us empathetic, connected, and protective of one another?
Because if nobody's broadcasting distress, maybe nobody stops to help anymore. That is a heavy, fascinating thought to leave on. Thank you so much for bringing your expertise to this deep dive.
It was a pleasure to unpack all of this with you.
Remember, that alarm system might be exhausting, but it built the human race. Keep questioning, keep learning, and we'll see you next time.